And we're live. All right. Okay. Here. So indices means A to the power of M, something to the power of something else. For example, if I write 3 to the power of 3, it means 3 multiplied by 3 multiplied by 3. That's what it means. Now, taking it a step further and quicker, if I say x to the power of 8, means x times x times x, 8 times. That's what it means. All right. I can say x to the power of 8 multiplied by x to the power of 5. What do I need to do? I need to count the powers together. So it becomes x to the power of 8 at x to the power of 5 equals x to the 13th. That's it. Simple, easy. Now, going with numbers, you can apply the same things. 3 to the power of 5 multiplied by 3 to the power of 2, 3 to the power of 7. Now, you should be careful where. If the base numbers are different, then you cannot do it. So if I give you 3 to the power of 5 multiplied by 2 to the power of 3, you cannot do anything. Well, you just have to do 3 times 3 times 3, and then multiply by 2 times 2 times 2. There is no answer like this. You cannot say, well, this is 6 to the power of 8. You cannot say that, because the base numbers need to be the same. Indices. So the same thing. If here was a 2x, you could have not done anything. You cannot say, well, this is 2x to the power of 8. You could not have said that. Yes? The base numbers have to be the same. Yes? Division. You can write division in a number of ways. You can write it with a division sign. You can write it as a fraction as well. It means the same thing. 3 to the power of 5 dividing by 3 to the power of 2. That's what it means. And when you have division, what do you have to do? Subtract the powers. That's it. Easy. Same thing goes again. If the base numbers are not the same, you cannot do it. Yes, going back to things that we did. So what about we have a complicated one? You apply the same rule as if there were only one. So what do you get? Multiplied by y. That's it. You just keep doing the same things over and over again. They just become more and more, but you keep applying the same principles. Nothing changes.
But that's possible a minus.
And we're gonna get there right now. Something to the power of minus,
Means that it's nothing, nothing out of the recipiente.
correct, means 1 divided by a. That's what it means. So if you get 7 to the power of minus 1, that means 1 divided by 7. Done, that's it. So you can further rewrite this in a different way. You can say y3 z3 divided by x, because it's x to the power of minus 1. Yes? So what if you receive a to the power of minus 5 multiplied by a to the power of minus 7? What then? You apply the same rule. Oops. Multiplication means addition. Yes? Plus minus means negative. You keep applying the same rules over and over again. Nothing really changes. Then you have addition. A to the 7 plus a to the 7 means? No. Why is it 2a to the power of 7? It's like saying, no, 1 plus 1 equals 2. I say, I have 1 apple and I add another apple. How many apples do I have? 2 apples. That's how you say it. A squared, correct. But when you add them, it's a completely different story. Same with like this. 8a. Done. That's it. 8a. Nothing difficult to it. But if you get this, then remember, they're not the same. If they're not the same, you cannot subtract or add them with each other. So the answer remains the same. 7a minus 3b. You cannot do anything. That's how it is.
7a minus 2a is 5a.
Now, a more complicated question. And put a number here. Why not? These two are not the same. So that's where you have to look out. They have to be the same, or else you cannot subtract or add them with each other. If it was multiplied, that's a completely different case. Completely different case. Then you multiply the numbers with each other, and then you multiply the variables with each other. 5 times 3, 15. A squared times a is a. 2 plus 1 equals Same with addition. You cannot do it. Stays the same. Yes? Same as it was B, for example. Same thing. Now, we continue and you keep applying the same principles. Oh, addition, subtraction. They have to be exactly the same or else I cannot add or subtract. They have to be the same. So for example, no, why not? Both of them need to be ABC in order to subtract. One is ABC, one is C. No, they're not the same, so it is not possible. Same with addition. Bam. Can I do it? No, because they have to be the same. Exactly the same. One has to be 5ABC plus 2ABC. Then it becomes 7ABC. If not, nothing happens. Stay the same. Multiply. You multiply first the numbers with each other. 3 times 2. 6. A times BC is, well, it gets multiplied with nothing, so it's just A. There's nothing to multiply with. And then you have BB. Not 2B, but B squared, correct. And then you have C squared. Indices. No. So now, technically, you can make everything. Do you know how to multiply brackets? Like this. 3A, A minus 1, minus A. 3A, A to the power of minus 1, minus A. So what was it? Everything outside of brackets has to multiply everything inside of the brackets. So 3A multiplied by A to the power of minus 1. What does that mean? You have to look at what does this only mean? Only this piece. What does that mean? That means 3A multiplied by 1 divided by A. That's what it means. So when you continue, it means 3A divided by A. Oh, you have 2 A's. Both of to the power of 1, you could say. You just don't write. So what can you do? Divide by A. It's 3A1 minus 1 equals 3A to the 0. And 3A to the 0, anything to the power of 0 is 1. So here is written 3 times 1 is 3. 3. Everything to the power of 0. 500 to the power of 0 and so forth. Yes?